So what we're going to be covering for here is we are going to focus on doing our tape diagrams and then how proportions can also help. So you can either use a tape diagram or you can use a proportion to be able to solve some of these problems. So for problem number 1, there are 70 students in the school band. 40% of those students are 6th grade, 20% of them are 7th grade, and the rest are in 8th grade. We want to know how many band members are 6th grade, how many band members are 7th, and then what percentage is going to be the 8th. So there are tape diagrams that we can utilize, or proportions that we can utilize for some of these. So first thing I want to make note of is that the entire band has 70 students in it. This is considered to be the whole. Okay, if we were to create a tape diagram, one whole is considered to be 100% of your data. So when we're talking about the entire band, we're talking about 100% of the band. So you can write it as a percentage, 100%, or you can write it as how many students are in there, which how many students are in the band? 70 students, right? So you can either showcase it as 100% or you can showcase it as 70 total students. Either way, that's representing the whole band. So what we want to do is we want to create a tape diagram that takes this percentage and takes this number of students and splits them up into equal segments. So I happen to notice that both the 100 and the 70 are divisible by 10. So I'm trying to figure out how many boxes I can split this information up into. Well, I could split them up into 10 boxes because both 100 and 70 are divisible by 10. So I can have equal sections. So I'm going to split this up into 10 boxes. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 boxes. That means what I need to do is I now need to figure out what percentage does each box represent and what number of students does each box represent. So if we have 10 boxes, I could do 100 and divide it by 10, and that will tell me what each box's percent is going to be. So what is 100 divided by 10? 10, yeah. So that means each one of these boxes is going to be 10%. So the first box is 10%. The second box is going to represent 20%. If we do 3 boxes, that's 30%, 40%, 50%, 60%, 70%, 80%, 90%, and then 100%. Okay, so we are depicting the percentages for each one of the boxes. Now let's do the same thing for the number of students. If we take the number of students and divide it equally amongst those 10 boxes, then how many students belong to each box? 7. Very good. So I have 7 students at 10%. At 20%, it's now 14 students. At 30%, it now becomes 21 students. And we just keep adding 7 on to each of these values until we get to 70. Okay? So now from here, we can go ahead and answer the questions just using our tape diagram. Our first question is asking how many band members are 6th graders. Okay, so in the problem, it only tells us that 6th grade is what percentage? 40, right? 6th grade is 40%. So what I'm going to do is I'm going to look at my tape diagram and I'm going to find 40%. And it's going to tell me how many students. How many students are there? 28. So there's our response. At 40%, that's 28 students. Okay, now I can also, 28 6th grade. I can also use a proportion to solve that out. I know that 6th grade is 40%, so I can do 40% over 100%. I also know that the entire band, the whole, is 70. So all I'd have to look for is what's missing. the part, which would be the number of 6th graders. Once I set that up, I could do my cross product, do x times 100, do 70 times 40, and then I would solve, and I'd still get 28 6th grade students. Okay, so a tape diagram can be used, or a proportion could be used. Okay, let's do the question number 2. Question number 2 says, how many band members are there in 7th grade? Well, what percentage is 7th grade? 20%. So all I have to do is look at my 20%, which is right here. And there are 14 students that are 7th grade. And again, we could do our proportion, setting it up the same way. We want to know how many students out of the 70 is going to represent 20% out of 100. Okay, now for our third question, we can't use this part because we don't know how many students are in the band that are going to be 8th grade. So we really can't use that part, but we can use our tape diagram. Notice with our tape diagram, we said, hey, 40% of the students is 6th grade. So that's going to represent right here 10, 20, 30, 40% is 6th grade. Then another 20% is 7th grade. So how many boxes would I highlight for 20%? 2 boxes. So I'm going to go, okay, that 50 and that 60%, that's going to add on. So now I've got 60% of my population here is 6th and 7th grade. So what's remaining is my 8th graders, which is what percent? 40%. So this right here, 10, 20, 30, 40. That's my 8th grade. So 40% is 8th grade. All right, let's move on. For problem 2, Jada has a monthly budget of her cell phone bill. Last month, she went and did 120% of her budget. So she went over budget, right? If you stick to budget, you stick to 100%. She went over her budget because she went to 120%. That means her bill of $60 is over her budget. She did not want to spend $60. That's too much money. That was too much money. So we want to figure out what is her monthly budget supposed to be. So her monthly budget should be less than $60. If we were to write this as a tape diagram, we know that the entire tape diagram is going to represent 120%. We also know that the entire tape diagram is going to represent $60. Okay, so now we want to split it up into boxes. So last period I had somebody say, oh, well, they're both divisible by 20. Do we really want to draw 20 boxes? No. We want to try to figure out something small, but not too small. Like I don't want to draw 2 boxes. That's not going to give me much detail either. But what's a number that we could divide into both the 120 and the 60? What can we divide them both by?
20.
Okay, we just said 20 is too many boxes. We don't want 20 boxes. What's another number that they could both be divided by? Think a little bit smaller. 10, sure. We could do 10. We could do 6 boxes. There's all sorts of amount of boxes that we could do that's not too overwhelming. You don't want to go more than 10. You never want to go more than 10. 10 is probably the most you want to go for. Okay, so if we split this up into 10 boxes, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 boxes. So again, we're going to take each of these values and divide them by 10. Guys, what's 120% divided by 10? 12. Okay, so we're going to have 12%. We're going to have 24%. 36%, 48%, we're going to have 60%, then we're 72%, 84%, 96%, 108%, and then 120%. Okay? I don't quite like that though, because I want to show 100%. Are either of these 100%? No. So I'm going to try something different. Let's try a different value that we could go by. I'm going to go ahead and do that right here off to this side instead. Okay, let's try a different value that they could both be divided by. So we want to go smaller than 10. So what's a number smaller than 10 that can go into both of these equally? 6. Okay, we can do 6. Yeah. So 1, 2, 3, 4, 5, 6. So if we divide these by 6, that's going to be 20%, 40%, 60%, 80%. Oop, they're perfect. 100%, 120%. Okay, now we can divide 60 by 6. That means each of these is going to be $10, $20, $30, $40, $50, $60. Okay, so we've split it up nice and equally. We want to represent her monthly budget. Remember, her monthly budget is going to be 100%. So we're just looking at 100%, which is $50. Okay, if you were to set this up as a proportion, we know that our percentage right now is 120 out of 100%. We know that her part is 60 out of whatever her whole would be, which we don't know. We don't know what the whole was. But if we set this up and do the cross product, we would get $50. Okay, let's take a look at problem 3. All right, problem 3. Ed spent a total of $50 in all. 40% of that money went to the movies, so we want to know how much money did he spend at the movies. So we know that we need a tape diagram that's going to represent 100%, and we need a tape diagram that's going to represent $50 that he spent in all. Okay, how many boxes can I create then? You can create 10. What's another one that we could create? 5, right? Not 6, 5. Okay, we could do 5. Let's try to go a little bit easier, a little smaller. It makes it faster for us. So we've got 1, 2, 3, 4, 5. 5 boxes. If we divide 100% by 5, that becomes 20%. So 20, 40, 60, 80, and 100. If we divide 50 by the 5 boxes, that's going to be $10, $20, $30, $40, $50. Okay, so now we want to know what's 40%. So 40% is going to be $20. Okay, if we set this up as a proportion, it would be X over the $50 that he spent in all. We want to know what is 40% out of 100. So we would do our cross product and we would find that X is equal to $20. All right, go ahead and flip it on over to the back. Flip it on over to the back. Yeah. Huh? I'll go back to it because I have to keep going, okay? I'll come back to it. All right. Melissa went to lunch and got a salad for $8.50, soup for $6.25, and a lemonade for $2.65. Guys, when you go to a restaurant, do they give you a separate bill for the salad, a separate bill for the soup, a separate bill for the drink? No, what do? They sum it all up as a whole, right? They find the entire amount that you spent and they give it to you on one bill. So you want to do the same thing here. You want to add up all the items that you purchased. You're going to add all those items that you purchased together. So we're going to find out what our whole is going to equal. So we're taking $8.50. We're going to add $6.25, and we're going to add $2.65, and we find out that our entire cost of the meal is $17.40. Okay, so now we can set these up. Remember, we set this up as a part over whole equals percent over 100. So the part that we're solving for is how much did her server make off the meal, which is called the tip. We need to figure out how much money the tip is going to be. That's all we want to know. How much will the server earn on the meal? That's just called your tip. Okay, we know that the whole is the entire cost of the meal so far, $17.40. We know that the percentage is the percent that we're tipping, which is 25%. So are they getting $25? No, they're getting 25% of what you spent. Okay, so now we can set up as a proportion. X over 17.40 equals 25 over 100. Then we can do our cross product. Remember, cross product means we multiply our diagonals. I'm going to multiply 100 times x to get 100x. I'm going to multiply 17.40 times 25. That's going to give me 435. Okay, then I just need to solve. I need to go ahead and divide both of these by 100, and that gives me my tip. We are going to give the waitress $4.35 for the tip. Okay. All right, problem 5. Bill's purchasing a new phone. The phone costs $899 and tax is 7.5%. How much money is Bill going to spend on the new phone? So if he's spending money, he is going to buy the phone and he's also going to pay tax. So he pays for the phone, he pays for the tax. That means you're going to do this whole process, but at the very end, you're going to add it to the cost of the phone. You have to do the exact same process, but then you have to add it to the price of the phone. So our part is going to represent our tax money that we don't know. Our whole is going to represent the $899 that the phone cost. And our percent is the 7.5% for sales tax. So we're going to do x over $899 equals 7.5 over 100. And then we cross product. So when we cross product, we're going to get 100x is equal, if we do $899 times 7.5, that's going to give us 6,742.5. Now, once I divide both of those by 100, I'm going to get a value that does not represent a penny amount. I'm going to get $67.425 for my cents. That's not a proper way of writing money. Which one of these numbers represents where the penny goes? The 2. The 2 represents where the penny goes. So that means I have to look at the 5. Is the 5 telling me to let it go or give it a shove? Give it a shove. 5 or above, you give it a shove. Remember, 4 or below, you let it go. 5 or above, you give it a shove. So we are going to go ahead and shove this number up to its next value. What's the next value above the 2? 3. So this becomes $67.43. 43 cents is what it's going to become. Okay, that represents the tax. That's how much money in tax we're paying. Now we got to do the extra because we want to know the entire cost of the phone. How much is he going to pay for the phone in all? We're going to add the cost of the phone and the tax for the phone. We're going to add the cost of the phone and the tax for the phone. That's going to come out to, that's $966.43. $966.43. Okay, let's take a look at problem number 6. Number 6, this is what a lot of people are doing right now. A lot of people are having to deal with problems like number 6 because we're all trying to do holiday shopping. And when we do holiday shopping, we're looking for the best deal, right? So I might go, oh, who's selling it cheaper? Oh, Amazon's giving me a coupon for a certain percentage off if I buy 2 of these items. But if I go to Target and I've got my 5% discount there because I have a card there and it's selling it for cheaper, which one's the better deal going to be? So you have to figure that stuff out sometimes. Okay, Amazon's not going to tell you Target's a better deal, and just like Target's not going to tell you Amazon's got it for a better deal. You have to do that research yourself, which means you have to know how to calculate it. Okay, so Charlie wants to purchase a camera. It's the exact same camera at Target as it is at Walmart. It just happens to be that Target is offering a $1 discount, $100 off of the purchase, whereas Walmart's offering a percentage discount. They're taking 40% off of their purchase price. Okay, so now you're trying to figure out who's got it cheaper. So let's start off with Target, the $100 off. So for Target, we're going to take whatever the original price was of $250, and all I'm going to do is subtract $100 off. That means Target is selling theirs for $150. So now we need to figure out, well, what's Walmart selling theirs for? So for Walmart, Walmart has 40% off of their price, which their price is $230. So we're going to set up a proportion. We need to figure out how much money are we going to take off, which is our X, out of the $230 that they're charging, if they're giving us a 40% discount out of 100%. Okay, do I need to show you guys how to do the cross product anymore? No, you guys understand multiply, multiply, divide, right? Okay, so once you do that, you're going to find out that Walmart is offering a coupon of $92 off. Is that as much as Target's off? No. But is Walmart charging as much as Target to begin with? No. So we got to see which one's still cheaper. So now we're going to come on over to here where we're going to say, okay, well, Walmart originally was charging $230, and now we're going to take $92 off. And that means Walmart's only going to charge $138. So who's the better deal? Walmart. Again, you've got to figure it out by doing the math. You got to find out what the percentage is as money, and then do your subtraction from there. All right, our last one. Becky is going to be a real estate agent. Guys, real estate agents can make a lot of money if you can sell a lot of houses. Okay? Is she going to earn $575,000 for selling the house? No. Okay? When a real estate agent helps you sell your house, that money that it's sold for, that money goes first to the bank to pay off whatever amount of loan you still owe them, and then the rest of the money goes to the seller, where the seller then is going to say, okay, here's my real estate agent's commission. So the commission that they're earning is off of the selling price. They're not getting paid all that $575,000. They're just getting a small portion of it. But 2.5% seems like a real small amount, but it comes out to a lot when you sell a largely priced home. Okay, so let's take a look at that. Set it up as a proportion. X is going to go on top. 575,000 is going to go on the bottom. 2.5% is going to go on top. 100 is going to go on the bottom. And then we cross product. We multiply, multiply, divide. So once we do that, we find out that the real estate agent is making $14,375 off of that commission. So if they sell like 10 homes, they're making a pretty good salary, as long as they're selling pretty well-priced homes. If you're selling something for like $90,000, then you're not going to make as much money, obviously. All right? Any questions? Fantastic. So we're going to go over real quickly a couple of examples of what to do if you come across multi-step equations. Or not multi-step equations, multi-step percent problems. So you have only been dealing with, oh, I've got a tip problem, or I've got a tax problem, or I have a discount problem, or I have a commission problem. What happens if you have to do tip and tax together? Or if you are going to go shopping and you get a discount and then you have to pay taxes? So these are considered to be multi-step problems. There's a process that you need to do. So my example number 1 is a tip and tax problem. So let's focus on example number 1. I call this the easy example. Example number 1 is our easy example. So if you have tip and you have tax, then all you have to do is add the percentages together and pretend it's just a single percent problem. Make sure you're paying attention, because you are only getting these 2 problems to help you with your assignment. Chris, you want to copy this down. Kendall, you want to copy this down. Trust me. If you have a tip and tax problem, you're going to add your percentages together and work it out like it's a normal single percent problem. So if my tax is 6% and my tip is 20%, then I'm going to pretend like I just have one value of 26%, and I'm going to set up my proportion like normal. So let's take a look at problem 1. Problem 1 is an example of a tip and tax problem. James bought a lunch for $15. That right there represents my whole. Tax is 5%. Tip is 15%. I have tip and taxes here. So what I'm going to do is I'm going to add my percentage for my tax plus my percentage for my tip. That means I'm going to add 5% plus 15% together. So how much is that going to equal? What's 5 plus 15? 20. So we've got 20%. So we're going to pretend like this problem is only giving us 20% as our percentage. Now we can set up the problem. We want to know how much is he going to pay lunch for. So he has to buy the lunch, and then he's going to pay 20% for tip and tax. So we're going to go ahead and set it up as X over our whole, which is 15, equals our percent. Remember, our percent is now 20% over 100. And then we do our cross product. Again, once we do our cross product, we're going to find out that X is going to represent $3. That is our tax plus our tip. Our tax plus our tip is $3. Okay, now the question's asking how much is he paying for lunch? So again, he had to buy his lunch, plus he had to pay for tip and tax. So how much did his lunch cost him? $18. Okay, that's an easy one. All you have to do is add your tax and tip together first, and then you can calculate it like a simple normal problem. The discount and tax problems, that's a longer process. That one's going to take 4 steps. If it is a discount and a tax problem, it's going to take you 4 steps to complete it. So let's take a look at number 2, which is a discount and tax. I want you guys to go ahead and split that little paper up into 4 sections and label them step 1, step 2, step 3, and step 4. Okay, we've got our 4 steps that we're going to follow. So step 1, in a problem like this, if we're buying a laptop for $650 but it's on sale for 20% off, and we have to pay tax of 8%, you only pay tax off of the discounted amount, not off the $650. You have to find your discount first. So the first step is to find how much money we're going to take off. How much money are we going to take off? So when we set this up, we set it up as X over what? $650. Good. Equals what over 100? 20 over 100, right? $650 was the original price. 20% is how much we're taking off. So it's 20 over 100. Then we can do our cross product. When we do that, we're going to find out that X is $130 off. So if it's $130 off, what do you think step 2 is going to be? Subtract, right? We're going to subtract. What are we subtracting? Very good, Chris. $650 minus the $130. So step 2, we're going to go ahead and subtract. We're going to subtract the cost, which was the $650, and we're going to take off the amount that we said we're taking off, which is $130 off. So once we've subtracted it, we're going to get $520. This is going to represent our new total. $650 was originally our total. Now 520 is our new total. So once we know our new total, we're going to find our tax. So step 3 is to find the money amount for our tax. So when I set up my proportion, it's going to be X over what? 520. Very good. X over 520, because we're not paying 650, we're now paying 520. So X over 520 equals what over 100? 8, right? 8%. It's now 8% for our tax over 100. And then we can do our cross product. Okay, once we do that cross product, that's going to come out to $41.60. That represents our tax. Okay, questions asking how much money are we going to pay? What do you think we need to do now? Now that we know our tax, what do we do with that amount? Add it to what? To the 520, right? We're going to take whatever step 2 was, which was our new total, and we're going to add it with our tax amount from step 3. So that's our last thing. You're going to add step 2 and step 3. You're going to add step 2 and step 3 together. So we're going to take 520 and we're going to add it with the $41.60. And that's going to come out to a final price of $561.60. Okay? In Google Classroom, you guys have 8 question quizzes. You get 1 attempt, but you do get redemption questions at the end. So if you miss some questions, you can choose up to 3 redemptions to do. So it's going to ask you, do you want to do 1, 2, or 3? What should you always choose? 3, okay? Unless it doesn't give you the option of 3. If it doesn't give the option of 3, it's because you didn't miss as many as that, okay? So you always want to take the highest number of options for redemption. You may work with somebody. Just keep in mind that your questions are in a different order.